Right, metals plus oxygen or with oxygen is one of the topics that will be tested in your cycle test next week. So I'm just doing a little bit of a video to give you some revision on how this kind of works. You would have at this point watched those videos on the flame test with the metals and water, but we're going to be only focusing on metals with oxygen. So the video that's the most important is a flame test. You can check out other videos on YouTube. They're all going to give you the same results. So our general formula is a metal plus an oxygen gives me a metal oxide. Our metals are always in the solid phase, except mercury, but we're not going to look at that one. Oxygen is always a gas. Oops. And a metal oxide is always a solid. Now, your metal oxide formula, we will always provide for you because you don't know how to name formulas yet. So that's fine. But you should know the formula for any metal and oxygen. So when I look at the metals, your options can either come from group 1, which is your alkali metals. They can come from group 2, which are your alkaline earth metals, or they can come from the transition metals. And common transition metals that they like to use are things like zinc, copper, lead. So you need to know these formulas: zinc, copper, lead. There's aluminium. They can give you nickel. They can give you, let's say, mercury. Right, so they can even give you things like tin. Right, so those are all the different metals, and they all of these metals, when they bond with oxygen, which is O2, always diatomic. Right, whenever you write oxygen in a chemical formula, it must be written as O2 as diatomic, and that's always going to give you a metal oxide. Right, so there are different patterns we can use, and we'll go through those patterns. But the first thing we need to look at is what kind of colors do these metals give us when we do burn them in oxygen. Now, when you looked at those videos on flame tests, these were the different metals that they looked at, and sometimes they looked at it as just metals, or sometimes they looked at it as plain and simple metals straight from the periodic table. So let's have a look here, and this is what I want you to note down or to understand. So if I have lithium burning, lithium gives us the color carmine. Now carmine is just a pink or a bright pink color. Now on your worksheet it tells you pink. You can tell me carmine, you can tell me pink, you can tell me bright pink, but that's if lithium is the metal that is being burned. Strontium is the next one. That's also a metal. And in this sense, that one will give you a red color. Calcium gives you an orange, but you can also say it's a red orange, if that was the color. You use the colors you saw in your video, so that's fine. Sodium will always give you a bright yellow. Borax has to do with boron, and boron is going to give you a yellow-green color. You should know these colors. Copper will give you green. Copper chloride is a little bit different. That will give you blue. So if you ever get copper, then I would suggest you go with a blue-green color. That way you cover both types of copper. Potassium, that's two different potassiums. It's always going to give you a lavender or a lilac or a purple. You can use any one. You have purple, violet, lilac, lavender, any one of those, if those are the colors that are burning. And then the other one is magnesium, which burns in a bright white. Now, if I look at where they belong, right? So if I look here and I look at group 1, if I look at group 1, group 1, I've got lithium, I've got sodium, and I've got potassium. All right, and the symbols are Li, Na, and K. All right, I know now that lithium, if I check my colors, is a pink color flame. Sodium, I know, is a yellow flame. And potassium, I know, is a purple flame. Right. Now we need to know the equation. So we're going to look at the equation. And we need to know what the balanced equation is. Now let's look at the first one. I've got lithium, which is a solid. You don't have to know whether it's solid, liquids or gases, but I'm teaching it to you now so that you can grasp that. Lithium plus oxygen, O2, is always going to give you Li2O. And that's a gas, and this is a solid. Right. Now this formula here, we will give you. You don't have to write it down. We will give you that formula. But there are patterns, and we learn the pattern for this one. There are patterns, you need to know the pattern. That way it's easier for you to write the formula. So if it's a very difficult one, we will give you the formula. So transition metals, we'll give you the formula. But for group 1 and group 2, you have to know these formulas. But I'll show you a way. All right, the next thing we need to do is balance. So Li and O on this side, we're going to draw up our chart. Lithium, I've got 1. Oxygen, I've got 1. On the left-hand side, I've got lithium and oxygen. Lithium is 2 and oxygen is 1. Now, all of that needs to be sorted out. So the lithium's not balancing, so I'm going to put a 2 in front of it. And now I've got 2 lithiums. Oh, sorry. My oxygen's actually, was 2. All right, now the oxygen's also not balancing. I've got 2 on the left-hand side, 1 on the right-hand side. So I'm going to put a 2 in front of lithium oxide. And that's going to make the oxygens 2. Great. But on this side, they're 2 as well. But look what happened now. You affected that lithium. So 2 times 2 is 4. So you've got to go to this side and put a 4 in front of it so it can balance out. Now this at the top here is your rough work. We will not mark rough work. So you've got to write a balance equation. So you're going to say 4 lithium solid plus O2 gas gives me 2 lithium 2 oxide, which is a solid. And that is your balanced equation for lithium. Right? Let's say I do sodium with you. And now the equation is the same. Na plus O2 is going to give me Na2O. Alright, so I've got Na and I've got O, and I've got Na and I've got O. Sodium, I've got 1 here, I've got 2 there. Oxygen, I've got 2 here, I've got 1 there. So what I'm going to do now is I'm going to change the sodiums. I'm going to put a 2 there. That's going to become 2. Oxygens are not balancing, so I'm going to put a 2 over here, and my oxygens are going to become 2. Again, I've affected that, so that's now sitting at 4. Now I've got to get this sodium to be 4. So I scratch out that, I put a 4 here, and now I've got 4. So the Na balance, the O balances. Alright? So I must write my final balanced equation, which is 4Na, which are solids, plus O2, which are gases, and that gives you 2 Na2O, which is a solid. But now can you see the pattern? Can you see the pattern? Look at that. And look at that. When I'm dealing with group 1, the balance equations all look the same. Look at the oxygen and the oxygen. Look at the oxide and the other oxide. Right? It's the same thing. So when I get to potassium then, I can say the balance equation for potassium is 4K, which is a solid, plus O2, which is a gas, and that's going to give me 2K2O, which is a solid. And that's my balance equation for potassium. So you need to know how to balance these three equations. Now, when I look at it, I know that for this here, have a look at what it looks like, this formula of the oxides. So it's on your worksheet, for group 1 metals, the formula for the oxide is M2O. Now this M over here is for the symbol of the metal. It's the symbol of the metal. So my oxides for group 1 are Li2O, Na2O, and K2O. And that's my whole of my balance equations for group 1. Right, so please make sure that you understand or that you went through your group 1s. You need to know the colors. You need to know how to write the equations. If I were you, I would memorize this formula for all the ones in group 1. Then you have group 2. All right, so let's have a look at group 2. The beryllium. I'm going to get this picture back. Okay. All right, now I have group 2. In group 2, so in group 2, my major ones are beryllium, magnesium, and calcium. So with these three, they need colors. So I know that beryllium is like a bluish white color flame. Magnesium is a bright white, and you can't look into it because it's too bright. And then calcium has a red or a red orange. The acceptable answer we're going to take is orange. So what you need to know for each of these is you need to know, for example, how to write the equations and how to balance. So let's look at the first one. So if I had beryllium, I'd have the equation. Now I'm going to show you a new thing here. You can have a word equation. You can have a chemical equation. Or you can have something called a picture equation. Okay, I'm going to show you how to do all three. Alright, so let's look at the first one, which is beryllium, number 1. So the word equation would be beryllium and oxygen combined to make beryllium oxide. That's your word equation. Your chemical equation is Be, still a solid, plus O2, which is a gas. And that's going to give you beryllium oxide, BeO, which is a solid. So that is what your equation looks like. Now that equation always has to be balanced. So we've got Be here. We've got O, so we've got 1 and 2. And here we've got beryllium here as well, which we've got 1, and oxygen sitting at 2. Now we need to balance. So if I look at my, oops, that's O2. Now when I'm looking at these two, for beryllium, it's balanced, but for oxygen, it's not. So in order to get this oxygen on the right-hand side to be 2, I'm going to put a coefficient of 2 there, and the beryllium is going to become, the oxygen is going to become 2 oxygens, but it also affects the beryllium because now I have 2 berylliums. When I go on to the left-hand side here, my beryllium's 1. I need it to be 2, so I'm going to put a coefficient of 2 in front there, and I'm going to get 2 berylliums. So my beryllium's balanced and my oxygen's balanced. Now you must write a balanced equation. We don't, like I just said now, we don't mark your rough work, right? So let's just have a look at that. So at the end, I need to write a final balanced equation. Skip the blue. So I write balanced equation. If you want to write balanced equation, you can do that too. You'll write 2Be, which is a solid, plus O2, which is a gas, gives me 2BeO, which is a solid. You must write this out as your final answer, so you show your marker that that's what you want them to mark, because you can't mark rough work, right? And the next thing you do, well, the next thing is something called a picture equation. Now with the picture equation, we use pictures to represent what's happening here. So the first thing you need with the picture equation is you need a key. Alright, so you need, the first thing you need actually is a balanced equation. Once you got a balanced equation, you need to draw a key. So now I'm going to draw the picture equation. Sorry. So what I'm going to do is, I'm going to say for beryllium, it's going to be a little white dot that will be represented by beryllium, and for any oxygens, a little bit of a bigger dot that has stripes in it, so that represents oxygen. Now I need to draw my picture. So it's 2Be, so it starts with one Be and then another Be, 2Be plus an oxygen molecule. And I know that oxygen molecules come in pairs, and that gives me my oxygen molecule. And if I add those two things together, I'm going to get plus, I'm going to get 2BeO. So for every oxygen, there must be one beryllium. So there's my oxygens, and I've got a beryllium attached to this oxygen and another beryllium attached to that oxygen. So essentially what I've got now is 2Be, two beryllium atoms, plus one oxygen molecule gives me two beryllium oxide compounds. Gives me two beryllium. So there's one and there's two. So that's how you write a picture equation. So you need to know for your test how to write all three. What does a word equation look like? It looks like this. What does a chemical equation look like? It looks like this, and it must be balanced. And then what does your picture equation look like? It must look something like this. So please make sure you know how to do all of them. And the next one we have is magnesium. All right. So for magnesium, I'm going to write my chemical equation, right? Equation. Right. I'm going to say magnesium plus O2 is going to give me MgO. Now I need to balance it. My magnesiums, I have 1. My oxygens, I have 2. On the other side, I have 1 magnesium and I have 1 oxygen. Now, I'm not happy with that because it's not balancing. So I'm going to put a 2 in front of the magnesium oxide to get, sorry, that was 1, to get 2 oxygens, but it also makes sure I have 2 magnesiums. Go to the other side, I only have 1, so I'm going to put a 2 there, and that makes that 2. So I've got that and I've got that balanced. So I must write my balance equation. It's going to be 2 magnesium plus an oxygen gives me M2MgO. Now if you look at the formula of magnesium and you look at the formula of beryllium, we'll notice there's a way in which that formula is written. All right, so I've got, so far, beryllium will make beryllium oxide, magnesium is going to make magnesium oxide, and calcium is going to make calcium oxide. So look at the formulas. There's a pattern. We'll deal with the pattern now. Now if I look here, it's 2, then 1, and then 2. I look again here at the magnesium one. There's 2, there's 1, there's 2. Now I need to balance calcium. Right, so I'll just orange. I can say calcium, the balanced equation for calcium is then 2 calcium plus 1 oxygen gives me 2 calcium oxide. I know because I can see a pattern here for group 2. That's what your equations are going to look like. So I can say elements in group 2, in group 2 will form the equation, the oxide MO. That's on your worksheet as well, where this M stands for the alkaline earth metal, which can either be beryllium, magnesium, or calcium. All right, and that's how you balance the equations for anything that's in group 2. All right, let's have a look at the transition metals. Then we've got transition metals. They don't really have a pattern, but what you can always know is that what you will be given is the name of the oxide, or rather the formula. What you need to do is you need to be able to balance and write the equation. Now the equation is always the same. It's the base equation. Metal plus an oxygen is going to give you a metal oxide. So I'm going to give you all the metal oxides of the transition metals that you may be introduced to. All right. All right, let's have a look. The first one you can get is aluminium oxide. They can give you barium oxide. They can give you chromium oxide. They can give you cobalt oxide, iron oxide, lead oxide, manganese oxide, silver oxide, and let's say they can also give you tin oxide, tin oxide, and they can give you tungsten oxide, or they can give you zinc oxide. Right, and I'm just going to put in all of the formulas next to it so that you know what goes with what. Right, these are your formulas for all of these. So aluminium oxide, barium, chromium, cobalt. Cobalt. Let's fix that. It's CO. Sorry, cobalt. Iron oxide, lead oxide, manganese oxide, silver oxide, tin oxide, tungsten oxide, and zinc oxide. So these formulas you will have. You just need to write the equation. So what we're going to do now is we're going to write the equation for a few of them. So aluminium oxide is made by a metal and oxygen. So I can say Al plus O2 is going to give me Al2O3. Now it's not balanced, so I need to sort that out. O. Aluminium's 1 and 2, and 2 and 3. All right. first thing I want to sort out is the aluminium, right? So just bring another color in there. I need 2 on the left hand side, so I'm going to put a 2 there, and the aluminium becomes 2. Now my oxygen, there's a 2 here and there's a 3 here. Now I need to bring that to a common number. So if I say 2 times 2, I'm going to get 4, and then I'm going to say 3 times 2, I'm going to get 6. So that's a problem. So I need to find a multiple of the two numbers. So the number that it comes to is 6. Now how do I get 2 to become 6? I times it by 3. So I'm going to put a coefficient of 3 there, and oxygen becomes 6. And how do I get 3 oxygens to become 6? I need to put a 2 in front. And now my oxygens are 6. But by putting this 2 here in front of aluminium oxide, it's become 4 aluminiums. Now my aluminiums don't balance, so I go back onto the other side and I put in a 4 there, and now my aluminiums are 4. So my balanced equation then is 4 aluminiums, still a solid, plus 3 O2, still a gas, is going to give me 2 aluminium oxides, which is a solid. And that's how I do a balanced equation for aluminium oxide. All right, I'm going to do another one. I'm going to do cobalt oxide. You'll do the other ones. If you want me to mark it, you want me to check it, I'm more than happy to do that. You can just send it to me. All right, the next thing is cobalt oxide. So I say COO2. Oops, that's my formula. That's my oxide. So I'm going to say cobalt, CO, plus O2, and that's going to give me CaCO2. Don't forget when you're writing this out, the second O of cobalt here is small. Right, I've got CO and I've got O, and here I've got CO and I've got O. Now my cobalt on this side is 1 and my oxygen is 2. My cobalt on the other side is 1 and my oxygen is 2. So what I'll notice here about this one is that my right hand side and my left hand side already balance. So you must still write balanced equation, and you'll say CO, which is a solid, plus O2, which is a gas, will give you COO2, which is a solid. Right? And that's your final balance equation. Sometimes they give you this, you're going to try and balance it. Don't fall into a trap. Make sure you know it's already balanced, because I can see my numbers already balance out here. All right, so that's cobalt oxide. If I do lead oxide, that one looks a little bit different. Let's go and have a look at lead oxide. Lead symbol is Pb. So I'm going to say Pb, lead, plus O2, oxygen, gives me Pb3O4. All right. Now I've got that set up. Let's have a look. Pb and O, and Pb and O. Lead I've got 1, oxygen I've got 2. Lead I've got 3, oxygen I've got 4. All right, let's start balancing this out. So my lead's not working out. So on my left hand side, I'm going to put a 3, and my lead's going to become 3. And now my oxygen's sitting at 2 and 4. Now the nice thing about 2 and 4 is that if I say 2 times 2, I can get 4. So I'm going to put a 2 in front of my oxygen there, and my oxygen is actually now 4. So my lead is 3 and 3 balances. My oxygen is 4 and 4, and that balances. So when I write my balance equation, I'll say balance equation is 3Pb plus 2O2 gives me Pb3O4. All right, here's where the tricky part comes in. They can tell you to take this now, and they can tell you to draw the picture equation. Now, once we've got a balanced equation, then it's possible to draw the picture. I just need to draw up a key. So I can say for every lead that I have, I'm going to have a white dot, and that white dot is going to be completely colored in, and that will symbolize Pb. Then I'm going to say for every oxygen that I have, my oxygen is going to be an open circle, right, like that. Now I've got my key. So now they're saying, according to the balanced equation, it starts with 3Pb. So I'm going to go 1, 2, 3. color them in, right? Plus 2 O2 molecules. Now I know about oxygen, they come in pairs, so that's one molecule of oxygen, and there's another molecule of oxygen, and that becomes 1 Pb3O4. Right, now what that structure looks like, I'm going to draw it for you. It's a little bit different. There's a lead here. There's attached to that lead are 2 oxygens. Then there's another lead in between, and attached to that will be 2 oxygens, and then attached to that, so what I've got here essentially, right here, 3 lead molecules, 3 lead atoms plus 2 oxygen molecules, and that gives me a lead oxide 1 Pb3O4 or lead oxide compound. And that's your picture equation of that balance equation. So remember, number 1, you need a balanced equation. All you're going to do is you're going to say the metal plus the oxygen is going to give you the metal, let's make this smaller, metal oxide, and it must be balanced. Second thing you need is a key. Once you've got a key, the third thing that you need to do is you need to draw it out. You need to draw the equation out. You can use colors or whatever you want, as long as you're showing us a proper representation. So those are your transition metals. I can look at one more. Let's look at zinc oxide, right? So I can say Zn plus O2 gives me ZnO, right? Which doesn't balance. So I'm going to put a 2 in front here and a 2 in front here. And now I've got the balanced equation of zinc oxide. So you need to use your methods to get to the balancing. And if I have this type of reaction, it's called oxidation, which is a form of a combustion reaction, right? A combustion reaction. Now in this combustion reaction, you have 2, right? So if there is a gain, so let's put it like this. You could have, say like this, something called combustion. And you should know by now that combustion means to burn something. All right, now there's 2 types. Type number 1 is called oxidation. And how do I get oxidation? I must have a metal or non-metal plus oxygen. The other type is a normal basic combustion. And how I get that is, this is normal, like petrol, how petrol works, paraffin, gasoline, octane, propane, gas tanks work like this. We have a fuel plus oxygen, and that always gives us carbon dioxide plus water. Oops. Gives us carbon dioxide plus water. Now, if I think of I burn something, any fuel, oxygen must be present in order for this burning to happen, right? And in essence, I must get carbon dioxide, which is smoke, if I burn something. And water comes from the steam, because if there's heat, there must be a release of steam. So I'll give you a basic one. Let's say we have something called CH4, which is methane, plus O2, which is oxygen, will give me CO2, which is carbon dioxide, plus H2O, which is water. Right, that's my equation. Now I need to balance that equation. So on my right hand side, I've got carbons, got hydrogens, and I've got oxygens. On my right hand side, I've got carbons, hydrogens, oxygens. Now on my left hand side, I have 1 carbon, 4 hydrogens, and 2 oxygens. On the other side, I've got 1 carbon, 2 hydrogens, and a total of 1, 2, 3 oxygens. That's my setup now. So the carbons are fine. They're doing great. The hydrogens, there's a problem. The hydrogens, I have 4 on the left hand side here and 2 on the right hand side. So I need my right hand side to become 4. So I'm going to put a coefficient of 2 in front of water, and my hydrogens are now 4. But my oxygens have now become 2 plus 2, which is 4. Now if I look at these numbers, how do I get 2 to become 4? I need to times it by 2. So I'm going to go in front of water and put a 2 there. And now my oxygens have become 4. To my carbons balance, 1, 1, yes. Hydrogens, 4, 4, yes. Oxygens, 4, 4, yes. So my balanced equation, after I've checked everything, is CH4 plus 2O2 gives me CO2 plus 2H2O. And that's a different type of combustion reaction, which we get into later in the year. But you should know how to balance equations like this as well, because it's getting a little bit more complex. So those are your 2 situations. Now, another thing that's important to us is a test. Now, sometimes they ask you to tell if a beaker has 2 things, hydrogen or oxygen. Right. Now, if something has hydrogen, I want you to think of things like fireworks. If I have hydrogen, I'll take a burning splint. Alright, splint is I'll show you now what it looks like. Alright, so a burning splint looks like this. Let's add this. This is what a burning splint looks like. Now I'll take a burning splint, and when I put it into a jar that has hydrogen, it will make a popping sound. So how we do that, show you now. How we do that is, if we had this reaction, for example, and put magnesium into vinegar, and it reacts with each other, and then the test tube at the top will fill with a gas, and that gas is hydrogen. So the gas that I'm seeing here is hydrogen. And when you put a burning splint into it, it's going to make a popping sound. That's how I know I have hydrogen. Oxygen, a little bit different. Also going to take a burning splint, but the splint's going to be almost like as if it's dying. So when I put a burning splint in the presence of oxygen, it relights the glowing splint. It makes the flame brighter. So if I have oxygen gas in a test tube, it's going to make the flame brighter. That's how I know I have oxygen. And there's different tests for how do I know I have carbon dioxide, or how do I know I have water, or how do I know I have this or that, right? So these are the ones that you should know. And that's the end of that. But if you need help with anything, please send me a message. Now that you know metals with oxygens, please make sure that for this test, you know the group 1 plus group 2. You need to know the equations. You need to know the flame color. You need to know the apparatus. It's in your textbooks, but if I were you, I would Google it. Google the flame test experiment. You need to know how to balance the equation. You need to know word equations. You need to know picture equations. You need to know word equations, picture equations. You need to know chemical equations. You need to know what oxidation is. You need to know what combustion is. You need to know your general formulas for group 1 and group 2. All right, you need to know all of these things. Everything that's in this video is going to be tested in your exam. So please make sure that you know how to do it. All right.